Hey, Core 3. Since I'm out today, I'm going to kind of narrate you through the same way I would as if we were in class, so that way we can try to keep up with the pace. Typically, our class gets a little bit far behind, so I'm trying to do this video to help you follow along and continue learning even though I'm out. So we left off last time I saw you on Unit 3, Lesson 3 on Desmos. We were almost done with it, so we're going to finish up these last two slides right now, and then you're going to start working on Lesson 14. Just to remind you, your homework was to work on the Lesson 13 practice A and C on Schoology, so make sure that got done. All right, we left off on the activity synthesis, where we were talking about this problem that we did, where we had to determine the rotation degrees in order to move triangle ABC to triangle DEF. So what we discovered was that because we were able to come up with a translation, then a rotation of 120 degrees, then a reflection, and the triangles landed on top of each other, we determined that that makes triangle ABC and triangle DEF congruent to each other. If I can figure out a set of transformations that brings one triangle on top of the other triangle, then the two triangles are congruent. So let's talk about our lesson synthesis here, lesson summary. The three rigid motions are reflect, translate, and rotate. Each of these rigid motions can be applied to any figure to create an image that is congruent. To do a rotation, we need to know three things: the center, the direction, and the angle. Rotate ABCD 90 degrees clockwise around point P. This is what it would look like. ABCD, this parallelogram down here, getting rotated around point P. It kind of moves in this 90-degree angle. Everything moves 90 degrees clockwise, and here's your result. On this side, EFG, which is this right triangle over here, is rotating 120 degrees counterclockwise around point C. So you'll see it's making a 120-degree angle from where F starts to where F prime is. So what you guys are going to do now is you're going to try to determine the sequence of reflections, rotations, and translations that brings this parallelogram up here down to this parallelogram here. So in this box, you're going to type out the steps, like first translate, or first reflect, or first rotate, and then give the specifics on how to do that. What I have created for you is a link to a GeoGebra that has the same picture so that you can try out a bunch of things and figure out the steps. So if you go to the Schoology folder, you should be able to open up the link for the Lesson 13 cooldown. It's a GeoGebra picture, like I said, of this exact picture, and then try out using the transformation tools to figure out what do I do in what order to get this from here to here. There are multiple answers for this. It's a little bit hard to just kind of look at it and figure it out, and it would be easier to, kind of do a process of elimination practicing with the online tools, which is why I made that link for you. When you open the link, it looks like this. So you're going to use this button here for all your transformation tools. You can try reflections, you can try rotations, you can try to translate. If you're going to use translate and do a vector, remember you have to draw the vector first since there are none already in this diagram. But that should help you kind of try it out to see what you think will work. And our goal is to try to get this parallelogram on top of this one. So you're going to figure out the steps required to do that, and then you're going to go back and type the steps in that cooldown slide on lesson 13. After you finish that cooldown, the next thing you're going to do is you're going to go back into Desmos, and you're going to look for lesson 14. It's called Defining Rotations. When you open it up, this is your starter screen. You're going to just drag this button to represent how you feel today. Wherever you feel is absolutely okay. If you'd like to say a little bit more about it, you can type something here. And then you're just going to kind of move along in these slides. I'm going to move along with you. At some point, you might want, at different points, you're probably going to want to pause, do some of the work, then come back to the video so that we can kind of move along together, as if we would in class. All right, now that you've filled out that first slide about how you are feeling today, we're going to do this warm up here, which is our math talk. So you have a series of 4 slides where you're going to look at 3 different angles, and you're going to type in here which pair of angles you think appear to be congruent. So remember, we name angles using the 3 letters. This would be CBA. We always put the B in the center because it's the vertex. So you can name whichever 2 angles you appear to you to be congruent. You're going to type it in here. You're going to submit, and then you're going to give an answer to this question about how you could check to see if those 2 things were congruent. So pause your video here and do slides 2 through 4. All right, now that you have completed slides 2 through 5, actually, we are going to look at our learning targets for today. Just to keep in mind, when you were doing 2 through 5 and you shared your answer with the class, it is anonymous, so obviously you could see that you would get 3 responses that your other classmates had said. So you could read through their responses and see what they say and see if you agree with that, to try to see if you guys are on the same track. Feel free to go back and read them now if you haven't read them yet. Okay, so our learning targets for this lesson on rotations is I can describe a rotation by stating the center and the angle of rotation, and I can draw rotations. So those are our focuses for the next part of this lesson. All right, slide 7. So what we're going to do here is you guys are going to, you might want to make this full screen. It might make it a little bit easier. This actually doesn't make this any bigger. Triangle DCI has been rotated so the vertices of its image are labeled points. What is its image? So I might actually connect these here, DCI, so I can see that a little bit more clearly and make a triangle. All right, so I'm thinking that there could be a couple places where this gets rotated to that might make sense. So there's a couple of things I can see in here, a couple of triangles I can see in here that might make sense. It looks like WUV kind of looks like the same triangle, but kind of rotated in this direction. Right, as I look through the points, there's another set of points somewhere. Let me do a different color. These ones maybe? B, G, H. That might be also the rotation, but that rotation would go this way. So it seems like I don't quite have enough information. What is all of this information for? This is telling us like this point might go to this point, right? So if I look at that specifically, let me use a different color here. It says the image of C is G. That means that C goes to G, essentially. So if I'm looking at C, C is here, C goes to G. That might be helpful because that tells me that maybe this is the right triangle, this purple one. This red one looks pretty good, but it doesn't mean that C goes to G. C would have to go to U for that situation. So this first piece of information is kind of helpful. The second piece of information says I goes to H. I goes to H. So it's another piece that's kind of solidifying that the purple one might be the correct one. And then L goes to L, meaning L doesn't move. So L doesn't move. It doesn't move. So I have to think about what part of the rotation that might be if it doesn't move. U goes to C. Oh man, U would. Where is C? Oh yeah, U would go this way. V goes to D, so V would go this way. So I'm gonna erase these for a second. What do we notice? All the arrows are going in the same direction. All the arrows are going this way, so it must be going counterclockwise. But they didn't tell us that. But they gave us all this information that kind of led us to that. That's kind of helpful. So maybe it's BGH because it kind of all these arrows are kind of pointing and going in this direction. But I wouldn't have known how much to rotate. I would have known that I had to rotate. I wouldn't have known exactly how much to rotate. So it could possibly be this BGH triangle. So in here, I can fill in what I think it's going to be, BGH. And then it's going to ask me, what information did I find helpful? to help me determine the image. What information do I think I could use to make it easier? So that wasn't super easy. I had to use a lot of thought process in that. The image of G was helpful. And really that was it, because they told me the direction. They also gave me 2 of the points. Also told me that G and H had to be part of the new triangle after it was rotated. So that was helpful. What would have helped it and made it easier? Telling me the angle of rotation and the direction would have made it easier. Oops. Okay. Let's take a look at the next one. So it's very, very similar to the one we just had, all those same pieces of information, but now they're giving us a little bit more. The angle of rotation is HLI. The rotation is counterclockwise. Okay, that's what we were thinking. The center of rotation is L. So up here, remember it said L went to L? That makes more sense. If L is the center of rotation, it wouldn't move. So that's why it's saying L goes to L. So that kind of makes sense if I'm thinking about this rotation. See, L is here. It's also telling me that the angle of rotation is HLI. So what does that mean? HLI, if I connect those like an angle, that would mean it's going to move about this much, which is maybe 60 degrees. I can't really tell. Maybe 45. I don't know. It's hard to estimate. That's why we try not to do that. But it could be going this way or it could be going this way. Until it tells us here that it's counterclockwise, I wouldn't have known that I was going to go that way. So the rotation is happening that way. It's going about that much. It's following in a circle that's going around L. So the rotation is going in this direction. Okay. So it's the same information we had before. C goes to H. C goes to G, sorry. I goes to H. So those are part of my triangle. And it doesn't tell me again that D goes to B, but we can figure that out because it goes in the same direction, counterclockwise. And it has to have the same angle. So let me show you quickly how the angle piece comes into play here. So there's our image, but let me draw our pre-image. I think I'm reversing the colors from what I did last time. That's okay. If I connect D to B, you'll see it's going to be the same angle. The letters aren't the same, but the size of the angle is going to be the same. Kind of hard to see here, but from here to here is about the same, actually it is exactly the same number of degrees as from here to here. They're kind of overlapping, so it makes it a little hard. But in that math talk, you were looking for angles that are equal. Well, these angles would be equal in size. If it's a rotation, then they have to be. Wherever from D to B has to be the same angle of rotation as from I to H, which if I'm going to draw in the third one, let me use red, and I'm going to go from C, oops, I need the line tool, from C to G, oh, it's the same as the green one. It's also going to be the same angle of rotation. I didn't line this up right. Okay, so all of the points move the same angle. I don't know how many degrees it is, but I at least have a name for it this time. So I can be sure that now I can say the image of DCI is definitely triangle BTH. D goes to B, C goes to G, and I goes to H. Okay, what was helpful here is that they gave us more information. Giving us the direction and angle really helped to visualize it. What we found helpful was knowing the center was L made the fact that the image of L is L make a lot more sense. Okay, and then giving us the direction and the angle really helped visualize it. I don't think I would need any more. To make it any easier, it was pretty easy as far as we go. So you're going to have one more to do on this next slide. You're going to try this one out. It's a little bit different, gives you some information here. Same picture, but now we are looking at several points that are being rotated around a labeled point. So you have to precisely describe the rotation. So let me give you a starting, like, sentence starter for that. We're going to describe the rotation. We're going to say the points are rotated some direction. So you're going to fill that in. Figure out what direction it's rotating in. Around point something. Using angle something. So you're going to have to come up with those 3 pieces of information, and you're going to kind of fill that in. And that's going to be like your starter sentence. So try to use this information to help you determine the pieces that are missing, and then this will how you'll structure your description of your rotation. And you're going to submit that. Feel free to answer this question about what made it easier, what would make it easier. And then you're going to go ahead and move on to slide 10. Okay, so now that you've finished up to slide 9, the purpose of this activity is to emphasize that an angle, a direction, and a center of rotation are needed to precisely describe a rotation. So you'll notice in that first slide, they didn't give us that information. They only told us where some of the points translate to. We weren't told what the angle and the number of degrees were, or even where the angle was. We weren't told whether it was clockwise or counterclockwise. We weren't given the center of rotation. Those were all very important pieces of a rotation, and if I don't have that information, it makes it very difficult to determine exactly where the rotation is supposed to end up. So that was really what we should have gotten out of those last 3 slides, that the more information they have, and this specific information, knowing the angle, knowing the direction, and knowing the center of rotation, really help us to determine the image and where exactly it's supposed to go. And so that's very essential to having a rotation. All right, we've got 3 more slides we're going to work on today. So looking on slide 11, we are working on turning into triangles. So we're going to actually try using the transformation tools that are directly in Desmos today. You have a couple steps you're going to do. Over here you have the steps listed. Draw a segment, label the endpoints A and B. Rotate segment AB clockwise around center B by 90 degrees. Label the new endpoint A prime. Use the polygon tool to draw triangle ABA prime. There are 2 notes that are super important here. When we're using this tool, this rotation tool in Desmos, you do it in a different order. So you have to select the center, then you put in the degree, then the image, then you have to hit apply in order for it to actually do it. And when I'm making a rotation in this tool, specifically just to Desmos, to rotate counterclockwise, I have to make a positive degree. To rotate clockwise, I have to make the degree negative. So for instance, if I wanted to go 45 degrees clockwise, I need to make a negative 45 degree rotation. It's a little bit different in this tool than GeoGebra, although it uses very similar things. So the way you get to the tools is down here. You'll see construct and transformation, and there's a little arrow to pop up the menu. So I'll walk through this one with you. I want you to do it on your screen as well, though, so that you know how to use the tools. So first, I'm going to do construct. It says draw a segment, label the endpoints A, B. So I'm going to click on segment. I'm going to just draw a segment. In order to label the points, you have to click on the point. Oh, you might have to click the arrow first. Click on the point. Down here, you're going to check the box next to label, and then it will give you, it always starts with A. You can change that by typing in the box here. I'm going to click on the second point. I'm going to turn on the label, and it's going to label it B. So perfect. That's what I needed. When I'm done with that, I can just click out of it. So I've done the first step. Next, I need to rotate AB clockwise around center B by 90 degrees and label the new point A prime. So I need to click on the transform here. I clicked on define transformation so I can choose one. I want a rotation. So we're only going to use these top 3. Click on rotation. It tells me here what to do next. Next, choose the point in the center. It told me up here, rotate it around center B. So I'm going to choose B. Now it's giving me the option to enter my angle. I wanted a 45 degree angle clockwise, so I'm going to have to make it negative 45 degrees. Then it says select some objects to apply this transformation So that means I want to select what it is I want to rotate. I'm rotating segment AB, so I'm going to click on this. And then I'm going to click apply, and it's going to do it for me. So there is my negative 45 degree. Oh, I'm supposed to be making a 90 degree. Oops, let me fix that. So let me undo. Let me change this to negative 90 degrees. And there you go. You'll see it automatically does it for me as soon as I change it. So I am going to have to put a point on the end of this segment. So I'm going to have to go back to construct, click point, click on the end here and make a point. I'm going to have to use my arrow tool to click on the point and change the label. And it automatically does the next letter that we haven't used. So I'm going to change that to A prime. All right. So I've rotated it 90 degrees around center B, clockwise, and I labeled my endpoint A prime. Next, I'm going to use the polygon tool to draw the triangle. So here's my polygon tool. I'm going to choose a point A, connect it to B, connect it to A prime, go back to the original point, and I got my check mark because I did it correctly. So there's my triangle. Over here, what kind of triangle do you have? What other properties do you notice in the figure? So properties are things that we know are true about it, things that we think are true about it based on what we did. So we created it with a 90 degree rotation, so that should give you some information about the sides or the angles that you can write here. So you're going to enter your answer here, and then you're going to share with the class, and you're going to see some responses from other students. Then you're going to follow these directions on this one, same thing, and then you're going to go to the next slide, which is the activity synthesis, and you're going to stop there on slide 13, and then we'll kind of summarize together and finish out these slides when I get back on Monday. So happy lessoning. I will see you guys Monday. Make sure that you worked all the way through slide 13 here and you finished the previous lesson's cool down. Check to make sure your lesson 13 practice is submitted. If you have time, work on those rotation practices on Khan Academy. They have been assigned for the last 2 classes, so you've had time already to start working on them. Please message me with anything that is an issue or that comes up while you are working, and I will see you guys Monday. Adios.